Come on. Something's wrong. I might have to stop the stream, guys. Is this thing on? Is it working? I think it is. Hey, everyone, it's me. It's Dan Scoff, KNWA, Fox 24 Chief Meteorologist Dan Scoff. This is probably going to glitch out. It's April Fool's. It's almost over, thankfully, but we got a lot to talk about. We got a lot of details to go through. We got a lot of severe weather potential that's ahead. We even have severe weather potential tomorrow morning. I've been diving into this a lot over the last several hours. Let's get into it right here. So that is the music where severe weather is looming, and we have that potential for storms pretty soon. We're going to dive right into the timing because I know everything is nice and quiet now, but that's going to change here very shortly as we go into the early morning hours tomorrow. Now, there are uncertainties as to how strong these storms will be when they move in. How strong will the cap be? If you were wondering if I was doing a Facebook Live earlier, I was going to before the 9 o'clock show, but I was making some graphics and ran out of time. Surprise, surprise. Jake Fury, what's going on, man? My former audio guy. Man, we had some good times at this TV station. The TV station KNWA, not this building. You were in the old school building on the square. But Bradley, knowing that the Sinners, the cap has been an issue for them. So there's definitely been a lot of sin, convective inhibition. And I'll show you what I'm talking about. But let's dive into this. We'll break down all of the details. And I don't want to go super long because I'm kind of shivering. I think I'm getting sick. And there's a lot of nerves, obviously, ahead of a system like this and the potential for all these storms and multiple rounds of storms as well. So here's what we've got. Storm potential tomorrow morning. You can see that ramping up on your screen. This, by the way, is the forecast for the 2-day forecast timeline. We get a break in the action. Just don't be surprised to see a lack of storms during the afternoon into the early evening. So we are expecting a quiet weather period Wednesday afternoon into the morning hours Thursday. But then notice another round of storms ramps up Thursday around 4 or 5 o'clock in the morning, and then additional storms potentially. Taking the camera off the screen, you will notice that that storm potential will remain and cranks back up again. So there's a look at the Northwest Arkansas forecast. Your River Valley forecast is very similar. Quiet weather in the afternoon tomorrow, but storms in the morning, storms in the evening. So let's take you through the severe weather risk. First of all, I want to show you the big system here. So I'm going to show you exactly what I did on the newscast in case you missed it. we'll break all this down for you since I'm not rushed for time. But here's this giant low pressure system. First of all, folks, this is a beefy system. This is what we call a beast. This beast of a system is going to be just really causing a lot of issues. Here's the upper level low, multiple waves of energy diving in behind that. You've got what's called diffluence, storms that are nosing into Kansas. By the way, a confirmed tornado close to Salina, Kansas. Might even have put down a tornado in Salina. There's uncertainty on that. There was a little bit of a tornado report. Don't know exactly if Salina took a hit. So you'll be able to let me know. But look at all of that jet stream energy. This is bad, bad, bad news, folks, as this system will be developing a very, very active weather pattern. Now, here's those storms that just erupted, which, by the way, just to let you know, is under a I wonder why the severe thunderstorm watch doesn't show up. That should show up, but it doesn't. That's under a tornado watch to the south, but a severe thunderstorm watch. And there's been more tornado warnings in the severe thunderstorm watch this evening. Sometimes the weather does that. Yeah, those severe thunderstorm watches should show up, but they're not. But anyways, yeah, I saw that. Considerable. Here's a look at the surface map. Now, this is what concerns me. The warm front that's to the south is about to race northward. What does this mean? That means all the ingredients for low-level instability, for rotating storms, for all that stuff as that warm front lifts northward. That, if it makes it into northwest Arkansas, will lead to the potential for some significant storms. The winds are crazy today. You know that. Another wind gust 37 miles per hour at Drake Field. Here's a look at the fire and wind threat that was off to the west. That's the wind advisory. That's in Oklahoma. The tornado threat. There's the severe thunderstorm watch, by the way. And tornado watch makes it into south central Kansas. So that's what we're seeing right there. And then the flooding threat. So those are the things that we're watching. Now look at these southerly winds, not only in the low levels, but also at 850 millibars, over 50 knots expected tonight. And then that is going to lead to the potential for that warm front to lift northward. Now, what do I mean by that? It's already starting to make it. We have dew points in the upper 50s. This is rapidly increasing. The low-level jet probably underestimated by the computer models. Low-level jet is that area of winds about 4 to 5,000 feet above the ground, just pumping in moisture. And look at the dew point in Shreveport at 70. So it's very humid, and it will continue to get increasingly humid. Now watch this. As we put this into motion, you can see that moisture surging nothing but northward. Then it kind of dries out a little bit. And that drying is a little uncertain. Like what is causing that? I think the models are thinking some isolated storms might develop out ahead and kind of kill and sap the moisture, which would be a blessing because then that means we would have a cap and we would have only elevated instability, which would lessen the tornado potential. But there is a look at the temperature, dew point temperature climbing, and then watch this over time as that front pushes south. That just meanders right over our area. So we're going to have what's called overrunning precipitation. Hydra, we're going to show you all those future models, which I'm about to break down right now as we take a look at the severe weather risk. So what I wanted to do and explain this as best as I can is that these risks can be confusing, especially when the risk overlaps from one day to the other. So we're going to go back to the risk, and this is the day one convective outlook. Hasn't been many storms so far, right? Well, that's because of the cap, and I'll show you that in just a bit. But there's a look at the risk outline. Now, you might notice that the level 3 is northwest Benton County or northwest Delaware County. And then level 2 makes it into central and western Benton County and western Washington County. And then the risk kind of drops off over time. Well, why is that? Well, because our storms are expected at 7 a.m. and this risk ends at 7 a.m. So the amount of storm coverage, the farther east you go, the less likely you're going to have storms. So this is why that potential for severe weather drops off, because not necessarily the strength of the storms, which is a possibility, but I think it's the amount of coverage of storms at 7 a.m. because watch this. We're going to put the future track radar on here to show you what happens. So quiet tonight. Now, the models are thinking that this is some shower activity right here, and it very well could be, but I highly doubt that. This is where things get interesting. About 4 o'clock in the morning, the front is going to be moving eastward, and you will notice that at 4 a.m., those storms will start moving in. Now, here's where 7 o'clock in the morning, storms knocking on our doorstep. If you'll notice, in the eastern portion of that risk, there's not much happening, right? Well, that's why there's just a marginal threat. The coverage of storms will be less. But watch what happens when we overlap the day one to the day two. Boom. All of a sudden, more storms, and they'll continue. And now the risk increases. And so someone had a great question. Why did Northwest Arkansas get cropped out of the enhanced risk for tomorrow? Because it appears when the front pushes through, it'll stall out, and there will be additional storms in the morning hours on Wednesday or on Thursday morning. No, wait. Yeah, Thursday morning, there will be additional storms before 7 a.m. And that's why that enhanced risk is there. So watch this. Storms developing. Each one of these cells, even though they don't look like much, and remember, this is just a computer model. The computer model had no idea on the storms in Kansas tonight. They didn't have any idea about the isolated storms that produced some pretty massive hail in north central Oklahoma. So the models are pretty terrible, including the HRRR, in terms of getting storm activity exactly right. The models will be well underdone. Now, see what happens? 3 o'clock in the afternoon, the storms move out, everything kind of weakens, and we will get a break in the action. That's why we're saying we will get a break during the afternoon into the evening. But see that moderate risk the moderate risk in eastern Arkansas and the Missouri Boot Heel. But here comes the next round of storms, right around 5, 6 o'clock in the morning. And that will be additional storms that develop through Thursday, 7 a.m. Now, remember, that risk ends at 7 a.m. But guess what? We have another risk that will overlay that for the day 3 convective outlook. So there's the level 3, 7 a.m. to 7 a.m. is that timing. There's going to be damaging winds and tornadoes potentially, especially in the river valley. Now, speaking of that threat, this is for Wednesday morning after 7 o'clock in the morning and into Thursday morning, 7 a.m. A few tornadoes will be possible, and you can see the entire area is under the threat. So it all depends on where the storms will be. So just like what we have right here, Angela's asking, how about Elkins? I hope you guys understand. And we stress this every time. We are not good enough to predict exactly where a storm will be 12 hours in advance, or even less than 12 hours in advance, even a few hours of advance. You cannot know where a storm is exactly going to be. So to say that a city will get impacted by a storm, don't ask for specific places because everybody's under the threat, as you can see. So this is why you just have to pay attention to the weather. That doesn't mean that everybody sees a tornado in that area. It also means that not everybody sees large hail, but the potential is there for large hail, even where those colors are less. So don't just look at the colors and be like, oh, I'm in the one. I'm not worrying about that. Well, I got news for you. There were a lot of events where we were only under a 1, and that event still happened. We're not scaring you. We just want to prepare you. Damaging winds, possibility all over. So now let's look at the day 3 convective outlook. And guess what? There's storms potentially in the River Valley and Northwest Arkansas. And the timing for this is 7 a.m. to 7 a.m. So large hail, damaging winds, and tornadoes a possibility. Now we'll look at the future track here going after Wednesday. Here's another view. Wednesday storms. And I back this up all the way because this is a different model. We will see a break during the afternoon into the early evening tomorrow. Nothing wrong with that. But watch this, 5, 6 o'clock in the morning tomorrow, more storms rolling in, most likely in the River Valley. That's going to be a little bit rough. Then those storms move out, but guess what? More activity is developing, as you'll see. Storms focusing themselves in the river valley Friday morning, Friday afternoon, Friday evening. This continues into Saturday. And then there's again that timing. So that breaks it all down for you. Round in the morning tomorrow, around in the morning Thursday, a little bit of activity in the afternoon potentially. That's a little bit more questionable. That's why the probabilities are less. And then you'll see a 100% chance of rain all across the area. So, did I mention that there's 4 days, 4 consecutive days of severe weather? So you've got 7 a.m. Friday to 7 a.m. Saturday. All hazards will be possible still. Probably going to be transitioning to the flash flooding threat. So, what are the rain amounts, Lone Wolf? You'll see. I'm going to show you here in just a bit. So, this is the flood watch that's in effect. Now, I fully expect the National Weather Service out of Tulsa to issue a flood watch for our area by tomorrow. It might even be in the morning hours, honestly, that they issue the flood watch. So you'll wake up, you'll probably see Northwest Arkansas is under the flood watch, and that's what we're going to see for our area. Now, they already issued it out of Little Rock, and look at all of these storms. So you've got Friday morning into the afternoon, into the evening, and into Saturday morning, and that's some extremely heavy rain. Precipitable waters are through the roof. And then you'll see as we go into Saturday night into Sunday morning, some cold air wraps around. And no, your eyes are not deceiving you. That could be some winter weather. Not a lot, no impacts, but the potential for some pretty significant colder weather coming our way with northerly winds behind it. So that's what we've got there. Here are the rain totals that are expected by the models. We're not going to show individual numbers because that's too far out and that's too uncertain. However, there's a look at heavy rain amounts, and Northwest Arkansas, the European model is saying maybe less, and this actually trended down from what it was earlier. The GFS, however, is sticking to its guns, and it says, no, there's going to be more rain. And those purple shades, that's over 9 inches of rain. And you've got areas that are over 5 inches of rain in Fayetteville and Fort Smith. So we don't know exactly where the heaviest rain swath will be, but we do know that the potential for significant flash flooding is there. And remember, this is just a model. This model probably isn't even enough for the amount of rain. So here's a look at the widespread flash flooding that will be possible. And I got to stress this. You don't see day 3 moderate risks on a day, on a day 4. You don't see a level 3 on a day 4 ever, really. That's because those are only reserved for high confidence. But to be 4 days out with a moderate risk, that probably will lead to a high risk of excessive rainfall and rain totals 3 to 10 inches plus. So significant, possibly historic flash flooding will be possible. And there's so many things that we could show you, and that's what we'll do. We're going to go through parameters. I had so many things to cover in the newscast that I honestly couldn't even go over all of these parameters and stuff like that. Here's a question by Alex, and this is a good one. We'll see severe weather in the morning. I know it's not an exact science. I think, honestly, a lot of areas will. I think Benton and Washington County will see severe weather potential. I think the River Valley will as well. So that line, I don't know exactly where along the line, but the line will be focused basically from Northwest Arkansas to the River Valley. So, yeah, let's go for the Fayetteville fizzle. No kidding. So here's the instability. It's not quite here yet, but it's about to be. And as that surges northward, you can see it moving into our area at the same time, interacting with those storms. So we have fuel. And then you can see that threat. Now watch what happens. That instability clears out for a little bit and then races back to the north with elevated storms and severe weather potential kind of remaining across the area. So I got to show you this. Why did we not see thunderstorms tonight? It's all about the cap. Now, I'm not talking about, millennial talk where they say, no, that's cap. I'm cap. Nope. This is a cap in terms of a warm layer of air that's preventing thunderstorm development. Although maybe the model's not showing any storms was cap. But you will notice here that the darker the blue, the stronger the cap. So this is what I was making before the 9 o'clock. And watch what happens with those blue shades. See how they disappear? That allows for thunderstorms to pop up. So if you're wondering what the cap is, well, let me show you. The cap is a warm layer of air aloft that prevents thunderstorm development. So think about being in a hot air balloon. If you're in a hot air balloon and you've got surrounding air that's colder than your air in your balloon, you're going to continue to rise. You're just going to continue to go up in the air until that air surrounding you is warmer than where your air is in the balloon. And that's in the stratosphere. So that's where the top of the storms are. Now you'll see here, as we go to the cap, you have warm, humid air, which is what we're getting overnight tonight with that strong southerly wind. That's a few thousand feet near the surface. But then above that, you got a hot layer of dry air. I'll show you where that originates from. It's east of the Rockies. But that warm layer of air aloft prevents these thunderstorms from forming. Now, there weren't even really a whole lot of clouds. So that shows you that the cap was really strong and the upper level forcing just isn't here yet. But then that cloud kind of dissipated. So now during the day, another storm tries to develop and it gets close to breaking the cap. And that cap, again, is that warm layer of air because you want to get into the colder air. Remember, if you're in a hot air balloon, you want to be with air that's surrounding you that's colder than your balloon. That will allow you to continue to have to allow you to rise. And we'll look at the soundings and show you what happened. But there's a look at maybe the cap eroding. And this can happen by a multitude of ways. You can have a frontal boundary moving in, which will push those storms up a little bit. You can have a jet streak that comes in, which lifts the air, which cools it. You can get dynamic cooling in the layer, which can erode the cap. And a jet streak can also do that, causing enhanced lift. So there's lift aloft, there's lift at the surface. There's all sorts of things that you can even have horizontal convective rolls that just is enough lift where it pops the cap. But if it's super strong, you won't get a storm. But if you break that cap, guess what? That storm will rise all the way up into the stratosphere, and that's where you see thunderstorms blossom. And that did happen today, by the way, and I'll show you. But this is understanding the cap a little bit more. So that's a warm layer of air that comes from the higher terrain where the sun heats the high terrain of Colorado and New Mexico. Remember, it's very hot and dry. And that dry air gets transported with westerly winds. So it blows that warm air off the high terrain into the plains. And this is essentially a lid. This is the cap. And the cap is a warm layer of air that's above that warm, humid air, but it's a hot layer of air. And so that warm air, the cap, prevents thunderstorms from forming, which is exactly what took place tonight. And I'll show you the radar and how that happened. Sometimes storms can develop and they get literally choked off by the cap because it's so strong that it can't push through that warmer layer of air. However, if that cap erodes just enough, that's where you see thunderstorms start to blossom. So that's a little bit more of an explanation about the cap. And when we go to that convective inhibition, now that you know, the stronger the values, or the higher the values, the stronger the cap. And so there's definitely a lot of cap around. Now you can see it kind of weakening in the river valley. So I've got to pay attention to see if any storms will pop in the river valley. The models haven't hinted at it, but we'll see how this goes. But then you can see the cap starting to develop again. And then it erodes. And then it kind of builds back up, but erodes again. So that colder air aloft is working its way in, and then you just have additional storms that pop up. Remember, you got to have enough lift. And the answer is yes, there was a strong cap, but it wasn't as strong as what was expected. The models actually overdid the cap, and there was more lift. So that's the thing. We've got a lot of energy. I want to go back to this and show you. There is so much energy and support with this system that, there will probably be thunderstorms stronger than expected. That's why we're watching this system closely. Now, here's the nose of the jet, and look at those thunderstorms erupting. Right there, you can see the dry punch coming in, just a little bit of a streak. Those streaks right there is where you get the strongest lift. That's where those storms popped. I could take a look at another one here. And I know we're getting technical, but hey, you joined this Facebook Live, so we're geeking out. Here's another view as this loads. You will see, again, those thunderstorms erupting in Kansas right on the nose of that jet stream. So if we go to the jet stream and look and see what it's doing, you'll see that it's just now nosing in to Kansas, which is exactly where those storms have erupted. So here's the jet stream. There's the nose of the jet coming in. Now watch what happens over time. That nose of the jet lifts northward. It kind of translates eastward, and then it's going to park itself right over us. So this right here is known as jet coupling, where you have different quadrants of the jet causing a lot of rising. And then you see just more energy. And then finally it starts to kick out. So there's just so much upper level support. Let's take you through the vorticity map. And the vorticity map will really explain what's going on, because there's all sorts of energy moving in. And all this energy will probably be underdone by the models. The models won't be able to handle this perfectly. And we say it all the time. They don't resolve exactly what thunderstorms will do. So here's a look at the energy moving in, and then watch this low just kind of cut off to the southwest. What that does is that just feeds system after system after system. Think of it like this. Think of it like our ice storm in 2009, when we had January 26th through 28th as a positively tilted trough. And that's just what that's doing, is it's creating a fetch of moisture, constant interactions with moisture and instability. Only this time we're not below freezing, but we have that type of rain coming in. So this is a very, very heavy rain event, and then it gets elongated and it just sits there until finally it moves out. This is a recipe for disaster. So that is the GFS. That's the European. We'll show you the GFS real quick. Here's the GFS, similar solution. Low kind of sits there, parks itself, which, by the way, the GFS wasn't onto this earlier. And then that energy finally swings out and moves through, and then we'll see quiet weather, but colder weather by the end of next week. So that's that. Now let's take a look at what the atmosphere actually did. And we will look at the rotation tracks and all that stuff as well. But first of all, let's geek out and let's look at what's called the mesoanalysis. So the mesoanalysis is going to tell us what the atmosphere is like currently. And we're going to do a share screen. We'll do this. And these graphics aren't really made for TV, made for streaming. But we're going to bring this up, add this to the stage. There you go. What I'll do is I'll have my little window back there so you can kind of see me talking. I'm going to zip into this, make this a little bit closer. We'll go into the southern plains. First of all, let's go through all the layers of the atmosphere. So the surface winds, southeast, south-southeast, very favorable. The 925 millibar winds, we're starting to get that moisture transport, and it is racing northward. And this is purely out of the south. So anytime you have that, that typically spells trouble for our area. If we look at the amount of 850 millibar winds, we're talking already over 50 knots over us. That's extremely strong. 700 millibar winds out of the southwest, 500 millibar winds out of the west-southwest, and the 300 out of the west-southwest. Look at the rising motion that's starting to develop. What's interesting, too, is you look at this, and you will see that we have on Mega Doppler a little bit of returns trying to pop up. So maybe this is trying to break the cap, but probably having a difficult time to break the cap. We will. We'll ask the 8 ball. We'll see what happens. So let's go back to our analysis, our meso-analysis tool, so we can see exactly what's going on with the current atmosphere. Surface-based instability. It was not in place 4 hours ago. But again, those southerly winds, that's pumping in the moisture. And by a few hours from now, that will be in place over our area well in time before storms erupt, as you can see them off to the west. But the question is, will we be capped? So here's the significant tornado parameter. It's pretty high right now, but it is capped. You look at the significant tornado parameter effective layer, it's starting to nose in. We move along in time, you can see that increasing over us. And then it rapidly drops off. And it's kind of interesting how it does that. And I think the model's doing that because of the lack of, it's trying to develop some showers that will kill that low level instability, which, hey, I'm all for that. That'd be amazing. I want to go back here. We showed the meso-analysis, but I want to go to a couple of things. I want to go to the observed sounding analysis, and I want to show you a 3Z sounding. This right here, folks, is your cap. So this cap right here, remember, you got a warm layer of air. Let me just make sure we're on this. Yes, we are. This is called a skew T log P sounding. And what you're seeing here is 72 over 65, temperature dew point. This is how the temperature increases or decreases temperature with height. This is how the dew point increases or decreases with height. So right here, we got what's called a inversion. The temperature is warming dramatically. This is probably due to a subsidence inversion. And what that is sinking air. And this is that cap, that warm layer of air. So anything that tries to break through this is known as convective inhibition, and it's pretty high. It's over 180 in the negative. That means you've got to get through that in order to see thunderstorms. So this is, while it's an amazing hodograph, the hodograph is absolutely off the charts. This is violent tornado parameter to the T, which is why we're so concerned if that low level instability does return. Now, this is Norman's sounding. It's not us. We'll look at some model soundings for us, but they do have this very strong cap, and the parcel process curve does not allow for the storms to punch through this area. And by the way, this is pretty deep. It goes from 850 to about 700 millibars. So this is the cap. If this was gone and it just went up like this, there would be a tornado outbreak right now in Oklahoma. But this little bit right here is preventing thunderstorms from absolutely erupting. So you might see a lot of stuff like PDS, TOR for the hazard and all that stuff. Not with that cap. That cap is just too strong. Let's see how strong the cap is in Springfield. It's a little bit weaker, but it's still there. Let's see what it's like. Oh, see, now it's not as strong, but that low level instability raced northward. And then there is the 0Z sounding. So not as much of a cap. It's starting to weaken, but then it's strengthened again. So that can happen over time. Parameters are off the charts. So that is what that is. I want to go to the comp map, and then I'll start answering some questions here real quick. So the comp map tells you a lot of stuff. First of all, here's the jet stream that's nosing in. Here's a look at the 500 millibar vorticity that's coming in. And there's, oh, boy, there's a lot of energy. We're going to see storm after storm after storm, just so many rounds of storms, and it's going to be something to watch. So anyways, I'll remove that. Let me answer some questions, and we'll start to geek out a little bit more. Very, very strong winds. Very strong winds in Fayetteville. Yeah, that strong wind concerns me. There's a lot of times where in the morning hours, a cold front moves in, you get storms that develop, and they get pretty nasty. So we'll go through the timing here. Let's look at some high resolution model data. These are updated every hour. Let's see what we've got. So here's a look at the future track. Quiet, right? Everything's quiet until about 6 a.m. Boom. well, that doesn't show much. Now it's showing more around 10 o'clock in the morning. So timing can change. I think this is a little underdone. Let's go out a little wider. Remember, I don't have much trust in the HRRR. I just think it's been terrible lately, and I think this model might need to be retired. It's not doing well anymore. It needs some serious revamping. Could be because of the lack of weather balloons that are being launched. I don't know, but there's 4 a.m. for storms. It shows isolated supercells. Those will probably be a problem as that cap erodes. And then you got some storms that are in the river valley around 7, 8 o'clock. Now, remember, that timing might not be perfect. And then it shows those storms coming through. Now, what's interesting is they don't look like much, right? But we know the ingredients are off the charts, especially if that cap erodes. So let's show you the SIGTOR parameter. This is a significant tornado parameter, and you'll see it probably increase during the morning hours. Yeah, there you see it kind of lingering around, and then it ramps back up again, and that makes sense. So we will have to watch around sunrise, 6, 7 o'clock in the morning, and going until about 10, 11 o'clock. Lot of instability. We'll show you the amount of CAPE that's available. So there's the CAPE that comes in. And now let's look at what he wanted to look at is max updraft helicity. So this will tell us if there's a potential for rotating storms to have rotation tracks. And there you see those supercells in northeast Oklahoma. And yeah, there's one that gets really close to Bella Vista. So that's just a model representation, but it shows you that tomorrow morning, we've got to watch this system closely, and we will. And that means, I need to get to bed here pretty soon. But that gives you an idea of that storm activity. Let's look at the supercell composite parameter. And you can look at any parameter you want. If you don't have any storms, you're not going to get as much. But it's something to watch for sure. So what is your favorite and most trusted model will you show us? Honestly, I don't really have a model that's trusted. The European does pretty well. And let's see what the European has for the short term, for the near term, because that's a good question. Now, remember, the resolution is less, but it will give us an idea. And the NAM it's really not doing well either. So our job is really difficult because you want to know exactly when storms will develop. Texas Tech was good last year, but it fell off too. Here's a look at, so that does show storms developing out west and then them coming through during the late morning into the afternoon. So honestly, I'd say the European is almost the best. There are several things that we can look at, by the way, including something called the EFI. This is called the European Extreme Forecast Index. And so this is a pretty substantial system. I know I'm not showing you this, but I'm about to. So this is called the Extreme Forecast Index. And what it is it shows basically if the European is predicting a storm system that's a little bit more than climatology. So we're going to go to a south central view that table, and this will allow us to zoom in a little bit. So here's the CAPE and the shear for Wednesday night into Thursday night. And you will notice that it is off the scales. So there is a chance that the river valley will see a tremendous amount of CAPE, which would lead to severe weather potential for Thursday morning. I'm concerned about Thursday morning, folks, in the river valley especially. And then you'll see here the CAPE and shear is still possible to be over what we expect for tomorrow morning. And so all those, and look at all these levels here. Look at the QPF. Watch this. This will show the potential for extremely heavy rain. So it's showing that it's tipping the scales that this could be a substantial flooding event. And I think it will be. I don't see any way that Arkansas escapes without any flooding. This will be a significant flooding event. I don't know if that's going to be exactly in Northwest Arkansas, but we'll continue to see that. Look at Mega Doppler here. There's trying to be some rising motion, and we can see that with the nosing of the jet, but it's still capped. So maybe we get some showers that develop underneath the cap, and that kind of kills that low-level instability. That would be great. That would be amazing. I hope that happens. So let's just recap all this. Again, we got 4 days of severe weather consecutively. We'll break down this on the 7-day forecast. So we've got an alert day for tomorrow morning, and I think this is definitely needed. As that moisture surges northward, the low-level instability starts to increase. 0 to 3 kilometer cape, that's an interesting thing. Let's look at that. Before I show you, I'll make sure that it's even worth seeing. So let's look. It still shows it off to the east. Yeah, that's because it doesn't go off far enough. Let me refresh that. Yeah, it's not worth it because it doesn't show it. Yeah, there's a lot of cape, but it's way behind. I don't know why it's so far behind. It only is it's not doing it right. Yeah, it only goes into the early morning hours tomorrow, so that's not going to help. But anyways, here's the 7-day forecast. Storm chances. Not raining at all times, but something to watch for sure. And all this storm activity will finally wind down late Saturday night and into early Sunday. Okay, so let's break down the timing again because we got some questions about sleeping and going to bed, and rightfully so. I get that. So I don't expect a whole lot of activity until about 6, 7 o'clock in the morning. So that's going to be maybe while some of you are sleeping, but that really starts to ramp up as those storms start to move in. Ingredients will be there for severe weather potential. It will be a little confusing, just to let you know, when you look at the new risk, because the new risk will be updated, and this is the problem when we're in between risks. So the day one convective outlook will come out before before 1 a.m. And when it goes to 1 a.m., it'll switch to the new risk after 7 o'clock in the morning. So it'll look like those storms will be moving east, but we still have to get through them. So there is an outlook that goes from 6Z to 12Z. So, anyways, here's a look at the timing. So overnight tonight, you'll be able to sleep and rest easy until about 6, 7 o'clock in the morning. Now, taking kids to school, the potential's there for storms. So here's the good news. We will be able to tell you once they pop up on radar who's going to be impacted because we can track them. We can let you know when they're moving in. Ahead of time, we can't do that. So that's really tough to do. But we can tell you ahead of time. Let me look at the graph here. The graph 3 kilometer. This is a different model than the HRRR. I was going to show this. And this is a look at the storms. Let's see what happens. So it doesn't really develop anything because it's all capped. It's all capped. But then look at the storms developing along the front. And then there's additional storms. So yeah, 6, 7 o'clock in the morning. That's got the right timing on there too. And then additional storms, I think there could be a problem late morning. So we get around to storms, and then we still continue to see storms by the late morning while kids are in school, while you're at work. So these are things that you have to think of to prepare for severe weather if we do in fact see this. 7 a.m. will be a little bit, I think, east of where the storms move through. So the timing will be okay. Here's a look at that risk. Increasing threat for tornadoes the farther northwest you go. This is just the day one, remember? So it drops off. But as we go throughout our day, those risks will shift eastward. Um, and then large hail and damaging winds, all a possibility. So, and then you look at the day two outlook, that shifts southeast and east, and it covers over northwest Arkansas and the River Valley. And that timing is valid from 7 a.m. Wednesday to 7 a.m. Thursday. If we look at this, you'll notice that we've got a tremendous amount of hail potential. The hail potential is through the roof. I want to show you something too here real quick, and then I'm going to shut this down. I'll answer a few more questions. I had a question about I saw it. I will get to it here shortly. But there's a question about a PDS tornado warning and then a tornado emergency. And so I will get into that. But let's just look at right now. If there were a storm that was expected to come through, and let's just say it's got a storm motion of about, I'm plotting this here, stand by. Let's say it's got a storm motion of about, I don't know, we'll go 245 at 30 knots. 35 knots. Plot the storm motion. That's trouble. So this is our hodograph program, by the way, that we've made. I'm going to add this to the. So you're going to notice, first of all, this is a very, 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 very impressive hodograph. The critical angle is near 90 degrees. Bring this up. 86.1 for a storm motion that's east-northeast. 0 to 5 meters storm relative velocity is 527. Look at the 0 to 3 kilometer, over 1,000. That is unreal. The shear depth is 378 meters. The shear magnitude is 42 knots. That's off the charts, folks. That's pretty rough. That's a deep, deep critical angle, and that's a strong shear magnitude. And that's 10, 20, 30, 40. Yeah. Man, oh man. And if we look here, we scroll up. This is for Fayetteville's south-southeast motions. The shear is impressive. Shear is off the charts. Look at the hodograph-derived data. We can look at a analyst tool here and bring up the analyst hodograph. And you'll see we can zoom in on all this stuff. So the scoff critical angle is 86.1 with a 0, and that looks like an updated one. We can zoom in on that hodograph, and there's the speed. So it goes from 16 knots to 31 knots to 34 and to 43 knots. Man, that is strong. That's a very, very, very impressive hodograph. So we can look at the hodograph at KSRX. We'll plot that. Here's a hodograph for KSRX, very similar. And we'll plot the METAR and plot the hodograph. And you'll probably see a very similar hodograph. So the shear is very impressive. For those that look at hodographs, for those that know what they're looking at, not quite as straight angle, but remember, we still have to get closer to the low-level jet, and that will increase. So there's your right mover, by the way, too. So pretty good critical angle, but the shear depth is not super amazing. It's only 3 knots, so it's not a very strong magnitude. So, anyways, that's some of the stuff that we've been working on behind the scenes, critical angle stuff. I know. You don't know what you're looking at. Those are for some people that are there's some really, really basically advanced people on here, and it would take forever to explain that. So let's just say we're not going to. We won't get into all that, but anyways, yeah, there you go. A lot of streamwise vorticity. Very much streamwise. Streamwise vorticity, it leads to strong tornadoes. So let me go through some comments here for the next. I'll go 60 minutes, and then I'm going to shut it down. So storms will be tall, very large hail potential. That's right. Extremely heavy rain. I'm very concerned about the heavy rain and flooding threat. We do have the 8 ball. Okay, so here's the question right here. Where is it? Hopefully it doesn't bounce back. Oh, here it is. Edward's question. What's the difference between a PDS and a tornado emergency? So PDS is a particularly dangerous situation. It's a strong tornado. It's got considerable strength, but it might not be necessarily hitting a populated area. So a tornado emergency is a violent, deadly tornado that is moving into a heavily populated area where loss of life will be possible. Loss of life is possible with any tornado, but more likely. So that's why a tornado emergency is the worst. But a considerable tornado means that you still have a strong tornado. It could become violent. It may be violent, but it's just not as it's not hitting a populated area. So that's what it is. So PDS is for a tornado is imminent happening, expect to cause a lot of damage, active, large, dangerous tornado on the ground, and you got to remember population takes that into account. I think MWAC has a good safety shelter, so we'll go through that. Is this more of a flash flooding or cumulative flooding? All the rivers going up. So the Arkansas River, I don't think is going to flood like it did in 2019 because that was just a whole different event. It was like a month worth of rain, but this could set things into motion. But a lot of this heavy rain won't fall in the Arkansas River Basin. It will for central and eastern Arkansas, but not for the Fort Smith area. So there's going to be the potential, though, for that heavy rain. Though I mean, we will see heavy rain. Cool. I appreciate that. That's awesome. Aloha. I wish I was in Hawaii, man. There's a guy by the name of Drew that's in Hawaii. He's a meteorologist. He does so awesome stuff. Such a cool dude. Watching the fellow Weller nerd Bolt VR chat. Yeah, there we go. Colby effect, do your thing. That would be nice. You know how school is anywhere you live? Yeah. We've got all those schools plotted on all those things. How about this? I always thought there was a really nasty storm. There was a certain ambiance. You could feel it, makes your hair stand up. I recall a magnificent skies before the May storm last year. Magical mammatus. Yeah, the mammatus are incredible. And that's a sign that you have a very crisp anvil. It's very windy. That windy condition shows you the storm is strengthening. I know it's windy, and that's not good. Are there shelters in Carroll County? So I'm kind of screwed, I think, if anything happens. So just to let you know, I'm going to show you this, but this is tornado safety, okay? This is what to do in a tornado. If you're new to this area, you don't know, this is what you want to do. It's really easy by spelling out the acronym DUCK. So downstairs is what you want to go first. Get as low as you possibly can. Under something, center of house, keep away from windows. Those are all those ingredients right there. Downstairs, under something, center of house, keep away from windows. So you want to get as low as you possibly can. Cover yourself with blankets, pillows, and mattress in the center part of your home. away from those outside walls, away from exterior walls, and keep away from windows. People are saying they can hear raindrops. There might be an increase in moisture, but don't know where you're at. But there might be some rain popping up in Waldron. We can kind of see some raindrops. We can also see that moisture increasing. So we look here. There's Waldron. Hey, look, there's a raindrop. It is. It's starting to sprinkle a little bit. Now, here's another thing, too. If you're in a mobile home, if you have a mobile home, get out of that. Need to hit that for a sturdy structure. Exactly, Sean. I was just about to do that. If you're in a vehicle, go into a nearby sturdy building or get out of your vehicle and into a ditch. That's the best thing to do. Never seek shelter under an overpass. If you're in an apartment, what you need to do is get into the lowest level of your apartment. Seek shelter in an interior room on the first floor of the building. Get to know your neighbor. If you don't know them, this severe weather season will be a good time to do that. Severe weather is possible in mountain home too. Second story apartment, you want to get to that first story. Should you expect your weather radio to go off? Probably, maybe in the early morning hours. Could be a severe thunderstorm or maybe even a tornado watch. That would be probably issued around 4 or 5 o'clock in the morning, and that will most likely include our weather coverage area. So if you have that. Yes, if we get all this rain ahead of time, that will kill the Cape. Oh, if you're at Shogun, then I'm going to be going over there and getting some food because that sounds pretty decent right now. I haven't had any food. I haven't had any dinner. All I ate was beef jerky, some Jack Links beef jerky. That was my dinner tonight. But the freezer, the bathroom would be good. And by the way, there was a tornado that went very close to Shogun's in Fayetteville, just west of the mall on March 30th, 2022. How about that? Yep, I know. And Peyton was one of them. He was telling people not to get under the overpass as he was under an overpass. It was kind of ironic. Okay, we hit the 1 hour mark. We're getting close to midnight. Let's do a little 8-ball action. Let's see what the trusty old 8-ball says. It was kind of hiding, I think. I think it wants to come out. Oh, 8-ball, where are you? Let's see. Aha, found it. It was hiding. It was like, no, I don't want to come out. I don't know, Frankie. You know we're not that. This is someone that really wants us to be super accurate, and this is very tough to do. To be asking if a tornado will hit at a certain time at a certain location. Now, when the storm is in progress, we can track it down, but we can't do that 12 hours in advance. That's impossible. All right, here we go. What's the question? I'm going to ask it. We'll start off with the most important one. Will there be a tornado that touches down in our weather coverage area? Better not tell you now. It always does that. Okay. Will there be severe weather in our weather coverage area? It says it messed up. Yes. Is that yes? That is a, or is that no? Yes, that's a yes. There will be severe weather. All right. Will there be a tornado in Northwest Arkansas tomorrow in the morning or anytime? Let's just say Wednesday. We won't say a specific time. Don't count on it. All right. So the 8-ball says no tornadoes. What about, this is what I think is going to happen. Will there be some really significant flooding from this system? Reply hazy. Try again. Will there be, how about this? Yeah. Will there be a tornado watch in our weather coverage area tomorrow? Signs point to yes. It's not bad. Will there be areas that experience historical flooding? Very doubtful. Okay. Will there be flash flood warnings? As I see it, yes. All right. Well, there you go. But remember, the 8 ball was wrong a couple times too. I'm just joking around, dude. Just having some fun. Now, seriously, if you think if I think there's going to be a tornado tomorrow, there's a lot of conditions that show it. You got strong low level winds, you got low level instability that's increasing. You've got very intense system. You got a cold front that's coming in, and a lot of energy. So all those things have the potential to bring severe weather and tornadoes. What are some things that can lessen the tornado potential? We could have showers and storms that pop up that aren't severe, that kill the instability, which is what is kind of showing right now. If we go to Mega Doppler, there you see that storm activity. If I shake it too much, then I don't even get to see it because it bubbles up so much. That's exactly that's exactly it right there. I just said that. So I don't ever like to down. I'm just watching this closely. I'm not saying this will happen for certain, but the winds are crazy strong, and anytime you get really strong winds like this, it's something's brewing. Got to be careful. Yeah, severe drought to significant flooding. That's the way the weather works. So, all right, last thing that you need to do is a couple things. Weather call next gen is a great way to get alerted in the morning hours. There's going to be multiple rounds of severe storms possible. So this is a weather call next gen. It's a service that we provide. It is a subscription service. It's $1 a month, $12 a year, but you can receive crucial warnings for severe weather, and it's only within the polygon. It works awesome. It really does. Weather Call provides up to the minute phone calls, texts, and emails where it gives you some really detailed information. It also gives you an all clear. You can get live radar, real time lightning strikes, safety recommendation actions, all sorts of stuff. Weathercallservices.com/KNWA nextgen. There you go. Denise says, I have it and it works well. Let's get through tomorrow. Exactly. Let's just go through tomorrow and then we'll get through tomorrow and we'll go on the next day. So I got to get to bed. Got to continue my Bible streak reading because I'm on a good one right now. And hey, I want you guys to be watching very, very closely these storms. Josh Rugger, Zach Gilday, myself, if it's bad, will be in here. Peyton will be out in the field. We'll have multiple storm spotters. We've got you covered. And I know everybody else does. I know there's many other people that stream. There's many other meteorologists. And so thank you for watching us. And I I make it a passion of mine to study severe weather and to learn more about it. So we will catch you guys later. Josh will be on when the storms are start rolling in, so we'll be ready to rock and roll. We'll keep you safe. We'll let you know everything that's happening as much as possible, but just be weather aware tomorrow. So have a good one. Thanks so much, guys. God bless, and we'll talk to you later.